Imagine a world where nature thrives, with trees swaying in the breeze, sunlight streaming through leaves, and animals roaming freely. It's a perfect balance, nature at its best. But this harmony is fragile. As forests fall and industries sprawl, smokestacks replace trees, and toxic gases cloud the sky. Global carbon dioxide emissions hit a record high of over 37.4 billion tons in 2023, intensifying the greenhouse effect and warming our planet. With a whale weighing up to 200 tons, we produced emissions equal to 183 million whales last year alone, melting polar caps, shrinking icebergs, and transforming landscapes. But there's hope. We're just not capturing carbon dioxide, we're turning it into something life-giving. Our project proposes an eco-friendly approach to carbon capture and transformation based on the powerful enzyme carbonic anhydrase. We use this enzyme to play a key role in our process due to its unique ability to efficiently convert CO2 and water into more accessible, water-soluble bicarbonate ions. We began by extracting the carbonic anhydrase enzyme, specifically the NCE103 gene from yeast. We start with extraction of the gene from yeast and isolate it. A plasmid is cut and the gene replaces the cut portion. This modified plasmid is then put into E. coli cells to multiply and then overexpressed in Pichia pastoris cells. However, this enzyme had a short life, so we had to switch to an alternative source of carbonic anhydrase, which would be used for further research in the project, and hence we extracted this enzyme from spinach, which had comparatively better stability. Next, we synthesized magnetite nanoparticles using co-precipitation method to form a stable Fe3O4 core. These were then functionalized with citric acid, introducing carboxyl groups on the surface. Finally, the enzyme extracted from spinach was immobilized onto these carboxyl functionalized Fe3O4 nanoparticles, creating an efficient CO2 converter. This setup is then integrated into a bioreactor. The captured CO2 here feeds microbes like algae, bacteria, fungi, and some other organisms, transforming emissions into usable biomass for biofuels, proteins, and antioxidants. This isn't just about capturing carbon, it's about crafting it into a diamond that shines for our future.